Okay, in this video I'm going to talk about the cyclic quadrilateral formed by an inscribed angle from the midpoint of an arc intersecting the circle and the chord. So basically, so we have a circle and we have an inscribed angle from a midpoint of an arc. So basically we have an arc. And we have a midpoint of this arc. So these two halves are equal. So then we have an inscribed angle, like arbitrary inscribed angle from this midpoint, so something like this. And then we have this chord for this arc, and and so this inscribed angle, it intersects the circle, so these 2 points, and intersects this chord, so these 2 points. So basically this quadrilateral, it's cyclic. So like if you denote the points, so let's say that this is A, B, this is M, this C, D, and this is P, Q. So the theorem is that the quadrilateral CDQP is cyclic. Cyclic, it means that it's inscribed in a circle. So there is a circle that passes through all 4 vertices of this quadrilateral. So basically a circle, something like this. Yeah. Okay, so let's prove the theorem. So you notice that like one of the criterion of a cyclic quadrilateral is that the sum of its opposite angles is 180 degrees. So we will prove that the sum of the angle CPQ plus the angle CDQ, right? So this angle, so like if I remove this, okay, so this angle plus this angle. Okay, so this angle CPQ, it's equal to the angle let's write it this way. So it's APM, or no. So the angle CPQ is the angle between 2 chords CM and AB, right? So it is so it can be expressed as half of the two arcs that these two chords form. So basically half of the arc AM plus CB, right? So there is a theorem that like basically if we have a circle and the angle between two chords, it's equal to half of these two arcs, half of the sum of these two arcs. So so the second angle we leave it as it is, or like we can write it as an arc, right? So CDQ. So CDQ it's an inscribed angle, so it's equal to the arc CM. So the arc CM, right? So so we have not the arc CM, but half of the arc CM, of course. Inscribed angle is equal to half of the arc which it subtends. So yeah, so basically here, so we can rewrite it as 1/2, and here we write AM, the arc AM plus so the arc AM actually is equal to the arc MB, since these are two. M is the midpoint of the arc AB, so AM is equal to MB, right? So we write this is equal to MB, and here we replace it with MB. MB, and we group it differently, so MB plus CM and plus 1/2 of CB. So CB, we leave it as it is. So now we see that this sum is equal to MB plus CM. What is it? So MB plus CM, this is simply the arc CB, this large arc. So this is 1/2 of the arc CMB and 1/2 of CB. So 1/2, well, CB, like it's better to write CDB. It's because like to remove any kind of ambiguity, which of the two arcs CB it is. CDB. So CMB plus CDB, this is simply the full circle. So this is equal to 1/2 of 360, so which is 180, right? So so the sum of these two angles is equal to 180, which immediately implies that the CDQP is cyclic, which concludes the proof.